Hi. This lesson and next lesson, we're going to be looking at direct and inverse proportion. This lesson will be on direct, and there'll be another video focusing on inverse proportion. We're just going to run through this PowerPoint, and we've got some nice examples to do, and some examples for you to have a go at to check how well you've understood it. So, a bit of a starter, some stuff that should be quite simple to us. So when Mo Farah runs at 8 meters per second for some fixed period of time, he covers 240 meters. So speed, distance covered, we've just filled in our table there. If he ran at 16 meters per second, well, what would his distance covered be? Well, he's ran at twice the speed, so he should run twice the distance. If his speed doubles, his distance doubles. If we think about him going half the speed from 8 to 4, well, then it should be half the distance. And from 8 to 24, that's 3 times the speed, so he should run 3 times the distance, so 720 meters. If we think about kind of the numerical relationship that connects these, so how can we find from the speed to the distance? Well, 8 times by 30 will get me 240. 16 times by 30 will get me 480. 4 times by 30, 24 times by 30. So there's a constant scale factor. Scale factor is just a fancy word for multiplying it by a number. Think about when we've done similar shapes, they have a scale factor. It increases or decreases the shape depending on the number. This has got a scale factor as well. It's common between them all, and it's just a way of kind of showing how it increases or decreases. So actually looking into direct proportion, we've got our table that we've completed up here. We've got this fancy notation. Some people just call it the fish. It's the direct proportion notation. So D is directly proportional to S, and I will write that above because this would be a really good thing to write in our notes. So D is directly proportional to S, and that is how we could write it out. Basically, when something's directly proportional, if one increases, the other increases by the same amount, and if one decreases, the other decreases by the same amount. Think of our example of running, or think of an example of buying stuff at a shop. If you buy more, you're going to pay more. If you buy less, you're going to pay less, and it's going to scale up at the same amount depending on what the cost of the drink or the crisps or chocolate bar is. And we could write the formula to this question up here. We could write that as D equals 30S, because we've times by 30 each time here. And we'd say that this is our formula. We'll see what this is later. And we've got a constant of proportionality, the fancy word for what are we always timesing by. Okay. A couple of examples. I will get to them black boxes in a bit. I didn't know how to make them pop up midway through, so they're just there now. So, Y is directly proportional to X. I always say write it as you read it. So Y is directly proportional to X. So Y fish X. I'm going to change that though. We don't know how to do any maths with a fish sign, do we? We like equal signs, and we like algebra, and we like numbers. That's what we know what to deal with. So our little tip here, we can basically replace the is proportional with, or in other words, that fish sign, with equals to K times by whatever comes next to it. So in this case, it would be an X. So instead of writing Y fish sign X, I'm going to write Y equals to K times by X. So KX. We don't write the times with algebra, do we? And that's basically going back to when we had our D equals 30S. That K is kind of in that place of the 30. Obviously this is a different question, and we want to go ahead and try and find it. Next of all, we want to use, we always get given two things. So when X is 3, Y equals 7.5. So if I sub in X equals to 3, Y equals to 7.5. That's kind of like saying we were given at the start 8 meters per second, 240 meters distance travelled. They were our two x and y values like we've got here. So if we sub this in, 7.5 equals to k times 3. So let's divide by 3. We've now got k equals to 2.5. Questions will say find a formula for y in terms of x. That will normally be your part A in a question. So when we want to find a formula, that is basically our second tip here. Where you've got this k, basically put your value of k there. So y equals to 2.5x. That means our value of y is always going to be 2.5 lots of our value of x. I mean, you can double check that by doing 2.5 times 3, you'll get 7.5. Now, this part would generally be your part B if this was like an exam question or something, and hence find the value of y when x equals 4.4. We want to use this formula we've just found. We want to use this. So we've got x equals to 4.4, so y equals to 2.5 times 4.4. So I'm going to get my calculator out. And that gets me y equals 11. The one problem people find with these questions is they seem very abstract, and you kind of just like, what's the whole point of this? And what is y and what is x, and what have I even done here? You've just done a load of, I don't know, you've done a load of rearranging and formulas and maths and stuff, and you're kind of thinking, well, yeah, y equals 11, but what does that even mean? That's something, hopefully, when we get used to it, we can see some real-life applications of this. It's a good way of kind of predicting the future. Y and x in this case are obviously just made up things, but we can do it with speed, we can do it with people's running times. I mean, predicting the future in the current whole COVID situation, they'll be doing some links with proportionality and some modelling. It'll be a lot more sophisticated than this, but this is kind of the basis and the first step of maths to start to look in towards that sort of thing. Second question. Y is directly proportional to the square of x. So I'm going to say y fish, the square of x is x squared. So when I go to write this, instead of writing the fish, I'm going to write equals to k times by. So this case is y equals kx squared. Then I've got my two values. I'm going to sub in my two values. So when y is 36, x is 3. So here I've got 36 equals to 9k, and then k is going to equal to 4. So my formula, it's not asked us specifically to do this, but we need to get it to answer the thing they've asked us. Our formula is going to be y equals 4x squared instead of y equals kx squared. So then finding the value of y when x is 5, y equals to 4 lots of 5 squared. Oh, don't know why that line's appeared. So then y equals to 4 lots of 25, y equals to 100. So on the next slide, there's two questions for you to have a go at once you feel confident with what I've done on this screen. So if you can have a quick pause and have a go at these two questions, and then I'm going to put my solutions up there for you. Okay, hopefully you've had a go at them. Part A, I'm just going to talk through it. So directly proportional to Q. So R equals to KQ. We substitute in our values of Q equals 12 and R equals 9 to find that K equals to 0.75, and we write the formula back out again. We then substitute in Q equals 17, so 0.75 times 17, we get 12.75. B is directly proportional to the square root of A, so that is B equals to K square root A. Sub in our values to find K equals to 5, and then find the value of B when A equals 25, so 5 times the square root of 25, that would be 5 times 5, B equals 25. So these questions will be on a PDF for you, posted, so you can have a go at them and the answers will be there too. So, thank you very much for watching. I'm going to try and end this video without displaying all my computer stuff. Nice and easy. Thank you.